Hi friends, in this video we are going to learn about what is pull up to pull down ratio of Nmos transistor, Nmos inverter driven by other Nmos inverter. So here I have two Nmos inverters, V input given here and V output taken here, right? And whenever I say an inverter, we have two transistors to which we give input to one transistor, and this is the depletion transistor. This is the enhancement transistor. This is called pull down transistor. This is called pull up transistor. So here we derive what is the pull up to pull down ratio. Pull up to pull down ratio enhances, or it is used to give the appropriate values, to take the appropriate values of omega by L length, W by L of each MOSFET, so that whatever input is there, it is collected at the output. That means V in should be equal to V out. Okay, when V in equal to V out, we get a voltage called V inverse voltage. V inverse voltage. Okay, that is equal to 0.5 VD. This already we have seen in Nmos characteristics. Okay, now to derive these equations, we need to derive this ratio. We need two currents, that is current flowing in pull down transistor, current flowing in pull up transistor. Consider first pull up transistor. Considering pull up transistor, it is what type of transistor? It is a depletion mode one. In depletion mode we have VGS is 0. As for the device, this inverter to work, both the transistors should be on. They should be in saturation mode. In saturation mode, we have IDS current as K omega by 2L into VGS minus VT whole square. Right? Now here for pull up transistor, I consider IDS equal to K into omega for pull up by 2 into L pull up transistor, and my VGS is 0. My VT is VTD. VTD. D denotes depletion mode transistor, right? So VTD. This is my first equation. Similarly, for pull down transistor, it is in enhancement mode. So my VGS will be equal to V inverse, which is equal to V input, right? Okay, as V in equal to V inverse and V in equal to VGS. This is my gate source voltage now. VGS, it is also equal to V inverse voltage. My current equation for this will be K into omega pull down by 2L pull down transistor, V in V minus VT whole square. Right? Now this is 2. Equate 1 and 2. Because since this gate is shorted with source, same current whatever there is ID flows through IL. Flows through the source of the first pull up transistor, and the same is coming into D transistor. Okay, if we neglect body effect, and in MOSFET whenever this gate voltage is 0, so we say that the same current flowing in the ID will be flowing IS to the ground, right? So I am equating 1 and 2. I get K into omega PD by 2L PD V in V minus VT whole square is equal to K times omega PU by 2L PU minus VTD whole square. Now cancel the constants. We have omega PD by LPD, omega PU by LPU. let ZPU is equal to LPU by omega PU. ZPD is equal to LPD by omega of PD. Okay, we are taking this ratio to the constant as a constant. Now this becomes this becomes V in V minus VT whole square by ZPD. ZPD is equal to minus VTD whole square by ZPU. Okay, now send this one here, cross multiply, we have ZPU by ZPD into V inverse minus VT whole square is equal to minus VTD whole square. Now take roots on both the sides. We have root ZPU by ZPD into V inverse minus VT is equal to minus VTD. Right? Now here this becomes V inverse minus VT is equal to minus VTD into under root ZPD by ZPU. Right? Cross multiplying. Now what I get is V inverse will be VT minus VTD by under root ZPU by ZPU. Okay? Here from this we get V inverse voltage. But we take a specific values for V inverse, VT and VTD. We get the aspect ratio as pull up to pull down ratio as I consider V in V to be 0.5 VDD, VT should be 0.2 VDD, VTD should be minus 0.6 VDD. For these values, when I calculate this ratio, it is 2 by 1, that is ZPU by ZPD will be 4 by 1. This is my pull up to pull down ratio for an Nmos inverter which is given by other Nmos inverter. That's all for this video. Thank you.